Okay, students, today we're going to talk about angle measures, drawing them, learning some vocab that goes along with it. Initial side is always the 0 degrees. Terminal side, what does terminal mean? Like if you have terminal cancer, it's going to end. So that's where it ends. So it's 0 degrees, 90, 180, 270, 20 more degrees, 290 degrees. Okay, remember, counterclockwise is positive degrees, clockwise is negative degrees. Okay. Now notice it's at 290 degrees. That's positive. So we go in the positive direction. If it asks for negative 70 degrees, then we would go right there and it would end at negative 70 right there. So 290 is the same thing as negative 70 because remember 360 degrees in a full circle. Okay, find an angle with a positive measure and an angle with a negative measure. They're coterminal. Let me say the same ending point, just like I just did up there. I just basically did that. We had the positive 290 or the negative 70. Okay, so 250. Oh, we don't even have to draw it. So you have 250 degrees, or you have 250 minus 360, which is negative 110. Okay. And don't forget, I could come up with 250 degrees over and over. Same terminal, coterminal, meaning that side, if I add 360 to it as well, or subtract 360 from it. Negative 140, we going back negative 140, or I can go in the positive direction of 360 minus 140, which is 220. Okay. So it looks like they want another angle besides this one, so they should have said it with another positive or another negative. Okay. All right, so the first part's drawing it, then find a positive measure. Okay, so I guess they don't want you to include the 65, so you add 360 and subtract 360. That's simple. Okay, for each of those. All right, convert between degrees and radians now. Okay, so 100, if I have my unit circle, 0, 180, that's the same thing as pi. 180 degrees is equal to pi radians. Okay, radians is the distance around the circle. That's 3.1415, etc. Whereas degrees is the angle measure itself. Radians are the actual distance around the circle. Okay, so 180 degrees thing is going pi radians around the circle halfway. Okay, so to rewrite the radian measure of an angle in degrees, multiply the number of radians by 180 over pi radians, because then the radians will cancel out. And I'm left with degrees then. If I want to go from degrees to radians, it's just 180 and pi are the same. That's why it's like multiplying by 1, because 180 degrees equals pi radians. They're the same. Okay. So if I want to change from degrees to radians, I put degrees in the denominator, so they cancel out degrees and degrees. I take the number, multiply by pi, divided by 180, and then my units is radians. Okay. Lastly, arc length for the circle. For a circle with radius r and the central angle, theta, and this is in radians. So if it's not radians, I got to first convert to radians. The arc length, or arc length S, deals with radian measure, doesn't it? I just got to say radians is the distance around the circle, or arc measure. So when I say the radius times theta, that means if it gives me in degrees, I have to change it to radians and multiply by the radius, and that will be the arc length. Okay. So we write each degree measure in radians and the radian measure in degrees. Since we're trying to cancel out degrees, the degrees go on the bottom, 180 degrees, so these cancel. And I have 45 Actually, it should be right there. 45 times pi divided by 180. That simplifies down to pi over 4 radians. And you could just say RAD for radians. You don't have to write out radians each time. If I want to go from radians to degrees, I need to cancel out the radians in the denominator, so the radians need to be on the denominator. Okay. Okay, so then I have pi's cancel out. 3 goes into 180 60 times. 60 times 5 is 300 degrees. So 5 pi over 3 radians is equal to 300 degrees. Find the central angle in the radians. So first, we want a circle's radius of 5 centimeters and a central angle of 135 degrees. Remember, this must be in radians to use the formula S equals R times theta. Theta must be in radians, as we just pointed out. So I have to convert this degrees to radians and then multiply it by the R, which is 5. So degrees to radians, again, degrees cancel out, so I make sure the degrees in the denominator, therefore radians in the numerator. Simplify 135 over 180 down, goes down to 3/4. You can divide each by 45. Okay. And that gives me 3 pi over 4 radians. That's 135 degrees, 3 pi over 4. And then I multiply that 3 pi over 4 times the 5, which is the radius. I get approximately 11.78. Okay, so we're going to round in nearest hundredth as they do there, follow their example. Okay. And so if it's already in radians, find the length of each arc. If it's already in radians, I should do R times the theta. That's it. It's already in radians here. So 3 times 4 pi over 3, which would be 4 pi. Exactly. All right, that goes ahead and answers those questions. 7 minutes.